Okay, thank you. Welcome to Vegas. Welcome to reInvent. It's still early enough in the week that you can all make a pre-noon session. Let's see if you can hold that stamina till Friday. My name is Brad Steele. I lead the startup business development team for AWS. We've got an awesome group of startups, some really, really cool hot startups here today to share with you their story about how they use S3 in combination with other AWS services to essentially punch above their weight, to really gain a competitive advantage over their competition. We are going to do this in a lightning round format. 4 speakers, each one's going to speak for just about 12 minutes, maybe a little less. Reserve questions for the end. We'll have about 8 minutes at the end for questions, so please accumulate your questions, things you want to ask, and hopefully you will have some. And just before we kick off, by show of hands, how many of you work for a startup? All right, I'm going to guess. We got about 200 people here, so I'm guessing that looked like maybe 100? I don't know, maybe a little less, so half the crowd. And how about from a large enterprise, however you want to define that, but a large, oh wow, that's awesome. Very, very cool. So it's about half and half, more or less. Really good to see the enterprise guys here as well. So great, so let's go ahead and kick off. I first want to introduce Will White, who is the CIO of Mapbox. Many of you already probably using Mapbox's solution in one form or another on a daily basis. Mapbox has a mapping platform that enables developers to design and deploy maps into applications that you're using regularly. Mapbox is one of the most sophisticated and innovative users of Amazon S3, and they've been with us on AWS since their inception in 2012. They're one of those few customers that we consult on a regular basis when we're rolling out new products and features out to the market. So Will's going to give a brief overview of how they're using EC2, S3, CloudFront together with their products, and how they've been able to overcome some of the increasing storage costs that they face as they've scaled very rapidly. Will, come on up.
Okay. Is this working? Is this one working? Oh, there we go. Thank you. Hey, thanks for that introduction. It's great to be here. Thanks everyone for coming out. I think there will be some good tricks that we can share, and we can really talk about how S3 has enabled us to do some things that we wouldn't have otherwise been able to do on other platforms, and that's really important when you're a startup. But the blend of the crowd here is great. I think that it's also important when you're an enterprise. So let's dive into it. What's that? Cool. I'm going to use the space bar. So Mapbox. Mapbox is about adding location to any application. We offer customizable tools and services like maps that help you see the world in stunning detail, geocoding that helps you find places and addresses, or it's like search, directions that helps you get from point A to point B. And all these services are delivered as developer-friendly, user-friendly SDKs that just drop right into an app. Together, they really help change the way people move around the world. That's our goal. We work with some of the largest apps out there, like the Weather Channel. They use our SDK to render animated weather maps with radar and satellite, and they also use our search, our geocoder, to help people find the weather for specific locations really quickly. We work with Airbnb. They use us on the web to render custom tooltips or markers on the map that show prices for properties that are available to rent. CNN helps people understand where news is happening with a custom satellite style and a map style. And then someone like National Geographic, they have a city guides app that guides people on tours of the world's most iconic cities. So all of this is running on AWS, and it has been actually since 2007 when we started building this entire platform from the ground up. So we're sort of a true born in the cloud. We have an advantage in that sense. We're true born in the cloud startup. We started with S3. That was the first Amazon service. Then we started using EC2 in 2007. We're powering over 55,000 apps. It says 5,000, but that's 55,000 apps. And this 200 million is now over 250 million users in each month that we reach with our API. So it's a huge amount of users and a pretty massive scale that is all being powered by our API and our infrastructure, and S3 is a critical part of that. In fact, S3 is our storage workhorse. This is what we like to think of it as. We really use it as a clearinghouse for data. So at its core, Mapbox works by taking sensor data, that's data from satellites, mobile phones, vehicles, any other sensors, taking that and ingesting that into our data pipeline and processing it into a format that makes it accessible on our API. So S3 is really the clearinghouse for that transaction. We take data from sensors, raw data comes in, it's processed on our EC2s. We're usually running on the spot market. So we're doing highly efficient, cost-optimized data processing on the spot market. And then we take those outputs and we store them on S3, those processed outputs, those are stored on S3. Then again, on our API, we're using EC2 to power our API. This is doing billions of requests a day, 3 billion requests a day, and all those requests are going through accelerated with Amazon CloudFront. So that's handling our caching some of these requests. The most popular objects are cached there. So and then those requests go out to mobile apps. So as you can see, sort of S3 sits at the center of this and also tightly integrates really well with other Amazon services like EC2, Spot EC2, and S3 make a great combination for very, very efficient data processing. And EC2 and S3 make a great combination for building an API that serves out a lot of data very quickly. So in addition to integrating with those two services, I wanted to highlight another integration that we really like, which is the KMS integration. So KMS is the key management service, which provides a hardware security module access, but you don't actually have to interact with the hardware. It's a virtual layer around the hardware encryption module. So this lets us encrypt our highly sensitive location data with a rotating key that expires after 12 hours, so that we can totally lock down the data that we put on S3. And if somebody doesn't have access to that key, that they lose access to the data. That key is stored on a physical device that is tamper sensitive, so that key is destroyed if the device is tampered with. So the tight integration with KMS and S3 is amazing because you can really just turn it on, and as you push data into S3 or pull data from S3, it's automatically encrypted or decrypted using a KMS key. So this is critical for maintaining our high-level security on our location data. The other obvious thing this is why we use S3 from the start, is it's just massively scalable. And so we're having over 2 petabytes of street and satellite data. This is, as you zoom into a satellite map, you're zooming in from the global level to country level to a continent to a state and to a city. We have to store the entire world at every level. That resolution is enormous. There's trillions of pixels that are stored on S3, and that comes to a pretty sizable amount of data. And we're scaling out to 70 billion requests on S3 every month. That's a combination of puts, gets, reads, writes, what have you. In addition to just achieving an amazing level of scale, it's also really burstable. So 2 petabytes is a good amount, but we can also burst that up really quickly to something like 5 petabytes. If we're doing massive data ingestion of satellite data, we get a new delivery of raw data from satellites. We need to process that. We can temporarily spike our usage up to 5 or more petabytes, and then scale that down, and whatever we stop using, that's immediately money that we're saving. We don't have to go out and buy hard drives. We don't have to go out and rack up servers to build out storage appliances or anything like that. We just delete the data. We stop getting charged for it. And then another one on the cost side is just the built-in cost-saving features. Multiple storage classes that I really encourage you to explore. One is infrequent access, which helps you save on data that you don't access very often. This is really good for us for that raw data that we are storing, the raw data that comes off a satellite. We'll put that in infrequent access because we really just access it once or twice as we're processing it, but we want to keep it in case we need to reprocess it later. So that's really good for very large files, large objects that you don't access very often. You get a nice discount with infrequent access. The other one is reduced redundancy storage, which is sort of great for the opposite. For the processed outputs, whatever you're generating from your raw data, store that. You can store that as reduced redundancy storage. And what that means is that you pay a significantly lower storage price for data that you don't need as durable. So what will happen is, at scale, you might lose a couple files here and there. It's not stored on S3 as many times as other files, as traditional redundancy storage. So these are amazing. These two features are amazing to use in harmony because they really complement each other. And so you can store your raw data in infrequent access, and then your processed output in reduced redundancy. And if you ever lose a file, you can just reprocess it. I know the other folks are going to be talking a lot more about strategies around a reduced redundancy. So just to wrap up here, I mean, the integration with other services, S3's integration with other AWS services, just the scalability, both in terms of storage and in terms of requests, and the built-in cost-saving features that you just turn on and immediately start saving money, especially, and if you want to get creative with them, you can save a lot of money. This is what's enabling us to do incredible things that without S3, we might not have been able to do. So it's really enabling us to ship some products that are pretty exciting. That's it. Thank you.
Great, thanks, Will. Next, I'd like to introduce Rob Hruska, who's the engineering director of Hudl. Hudl, this is a really cool platform. So it's a coaching and training software platform to analyze and improve athlete performance, and they have a heavy concentration within the high school football realm, but a massive market ahead of them. So Rob and his team are constantly dealing with the challenges of having to collect lots of video from many different endpoints in a time and cost-efficient manner, and to be able to turn that data, make sense of that, enable to turn that data around and now allow their customers to view and make sense of that data in a very quick manner. Rob is going to discuss how Hudl optimizes for performance and cost for the very storage-intensive video content infrastructure. Rob?
All right, thanks, Brad. So my name is Rob Hruska. I'm the engineering director at Hudl. At Hudl, we build sports software that helps teams and athletes win using video and smart analytics. So with Hudl, coaches will record video of their games or their practices, and they will upload that recorded video to Hudl.com, where we provide tools for them to help break down and analyze that video and share it out with other coaches, athletes, and analysts who can use it to better understand their game, to identify tendencies to improve for upcoming matchups, and also showcase themselves with features like customizable highlight reels and recruiting tools. We got our start a number of years ago in the American high school football space, but we now serve over 4.5 million users across dozens of sports in over 70 different countries. Over 145,000 teams use Hudl, from grassroots teams in club sports and youth teams, all the way up to elite professional teams in leagues like the NBA and the English Premier League. We rely heavily on Amazon S3 for a number of our critical path workflows, but that video that's recorded and uploaded by our teams is by far the largest and most significant for us, and the one that I'll probably talk the most about today. Our peak time of year is still American high school football season in the fall. A given game day Friday in September or October will see us uploading around 35 to 40 hours of video every single minute. Having done that for a number of years, we've accumulated quite a bit of video, over 8 petabytes at current count, and our projections show that by the end of this basketball season, we should be hitting pretty close to the 12 petabyte mark. In terms of objects, that's over 4 billion objects that we manage in Amazon S3. I'd like to spend a little bit of time today describing our video upload and storage pipeline, how we store it and serve it back out to our users. And then I think, like a lot of folks, we're always looking for ways to make things both faster and cheaper. So to that end, I'd like to talk specifically about S3 transfer acceleration, which we use to deliver a faster, better experience for our users, and the S3 standard IA storage class, which we use to be more cost-effective about how we manage our data. So this flowchart here shows the path that video takes through our system. This workflow is core to our success as a business. Video is the linchpin that we build all of our products and features on top of, so it has to be rock solid and reliable. Amazon S3 has served us really well as the foundation to build that workflow on top of. Users record their video with cameras or with our mobile applications, and then they use a client application to upload that video to a temporary bucket that's designated only for uploads. When that upload is complete, we queue an SQS message through our application servers that gets picked up by a CPU-optimized set of transcoding servers, which will transcode that video into different qualities and for better streaming support. They also generate supplementary assets like manifests for streaming and thumbnails for viewing on websites. Once those video processing servers are done with the video and transcoding, they'll move that video into a more permanent bucket where it will live in perpetuity throughout its lifetime. I'll note that once the video processing servers are done transcoding, they don't actually remove the video from that upload-only bucket. We rely on a lifecycle policy to automatically delete that after about 30 days. That gives us the opportunity to reprocess the video if anything goes wrong. It also improves our security profile just a bit because nothing actually has delete access into the upload-only bucket. Once the video is moved into its permanent bucket, we serve that back out to our users over Amazon CloudFront for them to consume on mobile apps, PCs, desktops, et cetera. I'd like to zoom in and talk a little bit more about that first step, that path that video takes from client device into that temporary upload bucket. As most of you are probably aware, video files can be pretty large. An average upload session for us involves around 2.5 gigabytes worth of video being transferred from client into S3. But that's a pretty variable number. It's not uncommon for us to have 50 or 100 gigabyte upload sessions in a single session. There's also a lot of inconsistency when it comes to upload performance. It's highly dependent on the network quality and the bandwidth available to the user. But even in the best case, we're talking about dozens of minutes to hours for a given upload session for coaches. And that's time that those coaches and managers are spending watching a progress bar complete and not actually getting into their video and analyzing it. So the faster we can make that progress bar move, the faster they can get to getting their jobs done and doing what they need to do. One way we make that faster is by using multi-part uploads, a feature of S3. Multi-part uploads help us improve the performance because we can chunk that video into smaller pieces, 10 megabyte chunks, and upload them in parallel, making better use of the client's network connection. They also allow us easier ability to resume uploads if for some reason the connection is lost. If we didn't have that in place, users would have to start those uploads over from scratch, which can be pretty painful when you're talking about dozens of minutes to hours. Another way we boost performance is using S3 transfer acceleration. So we have transfer acceleration enabled on all of our video buckets and have the ability to conditionally enable it for teams by switching the endpoint that they upload to. Having done this for a number of teams, we've seen that teams using those accelerated endpoints show about a 77% on average faster upload transfer rate, and a lot of teams see well over 100% transfer rate improvement. Our current plan is to use transfer acceleration to really boost the experience for our more power user teams that are uploading large amounts of video or really high fidelity 4K video that's extremely large. For them, it can save hours, minutes, days in aggregate off of their entire end-to-end upload times. So multi-part upload and transfer acceleration are a couple ways that we make things faster for our users. I'd like to zoom back out and talk a little bit about how we're using the standard IA storage class to become more cost efficient with how we manage our data. So in 2016, this year, we've made a really strong push to transition a lot of our content from standard storage into standard IA. We were initially fairly conservative about this. We really wanted to understand the cost implications in our modeling of how video is used before we went all in. So we started transitioning a lot of our much older content, years-old content, by setting a lifecycle policy on our buckets that would automatically move that content into standard IA and observing and continuing to remodel and reforecast our usage patterns based on that information. Our initial results were really compelling. There were no performance costs in switching content over, so we started to work that lifecycle policy inward throughout the year and are continuing to observe. The challenge for that is that the policy has to match the usage patterns of the video that we're transitioning. This histogram shows those usage patterns in aggregate for basketball video over its lifetime. The y-axis there is the number of views, the number of accesses of that video, and the x-axis is the number of weeks after that video was created and uploaded. And you can see how this might actually align with how video gets used by our coaches. Game video is really useful immediately after it's uploaded. Teams are looking to get in there and understand what they did wrong and what they did right to improve for their next game. And then it's continually used throughout the season, has pretty good usage, and even sees kind of a spike near the end of the season as teams go into the playoffs and resurface video from teams they played earlier in the season, or start to build highlight reels for banquets and to share out to recruiters to try and play at the next level. But you can see that it really drops off after that. And somewhere along that long tail is the point where the video is truly infrequently accessed by our users. And that's why we need to set the lifecycle policy to take the most advantage of the cost savings that, the storage cost savings that SIA offers. But we don't want to move it in too early, or we're going to end up paying more because the access costs are going to be higher if we make a mistake in our modeling and calculations. Our current lifecycle policy is at about 9 months. And we're still working that inward wherever we can. But we continue to measure and refine and remodel and analyze the cost and benefits of moving that lifecycle around. We want to make sure that we go through our highest traffic seasons, namely high school football season last fall and our current basketball season throughout the winter, before we really get aggressive with our transitions. Today, having done this throughout 2016, we're over 60% transitioned into standard IA. Of those 4 billion objects I talked about earlier, over 2 billion have been moved into standard IA this year. And having done that, we've seen a 40% lower cost per gigabyte year over year. And when you're talking about 8, 12, 15 petabytes of data, that is truly significant for us in terms of cost savings. One interesting observation we've made that could help us set a more accurate lifecycle policy would be rethinking the way that we store our video in Amazon S3 buckets. When we started Hudl, we split our video by team. So we would have a set of teams in one bucket, another set of teams in a second bucket, a third bucket, and so on. And that means that all of that team's video, regardless of the type of video that it is, game footage, highlights, et cetera, is all kind of sitting there co-located next to each other. That means that our lifecycle policy has to be more of an average for all the usage patterns of all of those different types of video, instead of being able to take advantage of usage patterns for game video specifically, for example. If we started over today, we might actually bucket our video more like the bottom row by the type of video it actually is. Game video in one bucket, highlight video in a second, recruiting video in a third, et cetera. But even though we don't have the most optimal bucketing strategy, all in all, we've seen really tangible cost efficiency benefits by being able to even generally move our lifecycle policies inward. So Amazon, particularly its storage capabilities, have been at the very, very foundation, very core of how we manage video at Hudl from the beginning. S3 has been that, that rock-solid foundation, and the continued stream of improvements, competitive pricing, and strong integration with other Amazon services have made it a pretty clear recurring choice for us over alternatives. Newer features like transfer acceleration in the standard IA storage class have helped us continue to improve and helped us continue to deliver better customer experiences out to our users and scale out our customer base while keeping our costs reasonable. Thanks.
Thanks, Rob. So our next hot startup actually is going to be giving away one of their products. This is really, really cool. So I just want to ask everyone to reach under their seat. I know it's a little cheesy, but just reach under your seat. Right in the front, there should be a stick. So one lucky person has a sticker in the front of their seat, right under it. Should be able to feel it. It's loose enough. Anybody? Anybody? No? All right, we got a winner. All right, stand up. You win your ring. I'll tell you. I'll bring this to you right afterwards. So, congratulations. Next customer or company obviously is Ring. I would like to introduce Jason Gluckman, who's the lead software engineer of Ring. Ring's developed a Wi-Fi enabled doorbell that streams live video right from a user's front doorstep to any device, a tablet or a smartphone. So Jason's going to give a quick overview of how Ring uses S3, Lambda, SQS, a GPU farm in AWS, and CloudFront together to collect and process data from this constantly increasing number of device endpoints, and then serve it back to the viewers on demand. Jason?
All right. Hi, guys. Hey, I'm Jason, and I'm lead software engineer at Ring. At Ring, we make the Ring video doorbell like these, and we also make solar-powered stick-up cams and other connected home devices. Anyone in the audience actually have one of these? Seeing some nods. Cool. So at Ring, our core strategy is, our slogan is always home, and we want to make secure communities and connect our customers to their home from anywhere. And because we're a video device, storage is one of the most important parts of our product, and S3 is a really core part of that. First, I want to talk about one specific feature that S3 enables us to do, and that's our neighborhoods program, which we just launched. These devices are really powerful deterrents because burglars are usually looking for an easy smash and grab. They don't want to see you in the house, so the first thing they do is go up to your front door and see if you're home. Now, if you answer on your phone, or they see one of these devices and they realize that they're going to be recorded, they usually just go down the street and try somewhere else. Now, the problem with a traditional security system, or even cameras, is that they usually don't link up. So you can't really help the person down the street, and they can't warn you if there's someone suspicious walking around. With the neighborhoods program, users can subscribe and send alerts to people in their area automatically. And so the more devices that you have in the area, the more powerful the system becomes, and this protection extends beyond your own home. And we did a study with the LAPD to quantify this. And in a single area, burglaries dropped by over 50% when we put rings on just 10% of homes. So bringing that back to S3 for a minute, the use case for a video that you only care about, like if you're talking to a package delivery guy from work to tell him where to put your package, and a video of a suspicious guy that you want to tell the neighborhood about is very different. And with S3, having the ability to use different storage classes and also use CloudFront as a CDN really makes it possible for us to distribute that video very quickly and efficiently. At Ring, we have some really big numbers. Just about 3 years ago, we would have been in the garage, and now we have a global deploy that's really dense all over the world. We support millions of devices and apps, and we have over 1 billion video events and growing very fast. And that's been a really big problem for us as we grow because we have to keep reevaluating our infrastructure. But with S3, it's not been a problem for us to manage our storage, even as we grow so much. This is a diagram of how we generally process video in our system right now. We ingest live video from our devices and apps through our application servers, and that gets uploaded into our raw buckets. Now, on these raw buckets, we use S3's event system to automatically trigger Lambdas and put messages into SQS. That's a really nice feature of S3 because we don't have to manage a dispatching system ourselves, and we can still be really highly responsive. From there, our GPU farm pulls jobs from the raw bucket, processes them, and puts them into our final buckets. And once the videos are in our final buckets, we use lifecycle policies to transition them between object classes, as well as user behaviors. Finally, the users can actually access that from S3 and watch their videos on their device or via PC or other devices. Now, we use a bunch of different storage classes to optimize our services in terms of cost and performance. The raw buckets use standard because it's more expensive, but it doesn't charge fees if you delete things early, and it has no read fees. The final products usually live in IA because we can get up to 60% savings on that, as long as the videos aren't being used so much, but we still get the speed of standard. We also use S3 Glacier to store access logs, which I'll explain a little bit more about that in the next slide. Finally, when someone shares a video, that's a very different use case for us. So for those videos, we can put them into CloudFront as a CDN, so we can serve that to many different users very rapidly. Now, understanding how our customers actually use their videos and when they use their videos is really important to us. This is a histogram of how and when our videos get accessed. And as you can see, the accesses drop off really quickly as a video ages. And in the first hour, we have 43% of our views. In the first day, we have 83%. And after the first week, we only have 6%. So given these numbers, we usually put things into IA very quickly. But there is a catch to IA. IA has a 30-day minimum storage fee. So if you're deleting things early, you get charged for that. And there's also a 1 cent per gigabyte retrieval fee. So every time someone watches a video that's old and in IA, we actually get charged for that almost a month's worth of storage, and we lose a lot of the savings. So it's really important for us to understand when to transition things. Most of our users don't watch these old videos, but you can see there's a long tail of videos that get watched repeatedly, and there are some users that delete their videos early. So remember those S3 logs I mentioned in Glacier? We can use those logs to build profiles of users to determine which videos belong in standard, which belong in IA, and when we should actually transition them. So IA gives us really huge savings over standard, but using a hybrid approach like that gives us twice the savings over just blindly putting everything into IA. Storage classes are really great for optimizing our costs, but we're also much more flexible with our infrastructure costs with S3. Most of our loads are not a flat line because we're a physical product and the world just doesn't work like that. So most of our loads look more like this, and many other persons' loads also look like this. This is a graph of a read load from one of our clusters over the course of a day. And as you can see, the peak to trough ratio on this is over 8:1, and over the course of a week, it's even worse. So if we actually had to provision for the peak, we'd actually be wasting over 40% of our capacity in this particular system. Now, we actually did try to do that for some of our systems, and one of the problems we ran into was we were growing so fast that it was even worse. We had to scale up in advance to deal with the lead time, so we were wasting even more over just the capacity wastage. With S3, that's not really a concern for us because we just pay for what we need. If we need more capacity, it's there for us, so we can be a lot more efficient with our spending. What is a really big concern for us is location. So we now sell directly to over 100 countries, and we have big concentrations of users pretty much everywhere. We've even had some people access our website from Antarctica. So this is a problem for us and a problem for our users to give them a good experience because we can't beat the speed of light. If we're serving a file from US East, the round trip time to LA can be over 75 milliseconds. Many places in Europe over 100 milliseconds, and to most of Asia over 200. And that may not sound like a lot, but it really stacks up and customers do notice. So to give them the best experience, we can use multiple regions in S3. And by doing that, we can get within about 50 milliseconds of the vast majority of our users. Using the multiple regions is also good for us because we can avoid any cross-region transfer costs. And it's also good for us when we're growing into new markets. When we tried to expand into new markets, when we priced out dedicated storage solutions, there are really high minimums and really long lead times, and that would really hurt our time to market. So when we want to go to a new market, now with S3, marketing just tells us where they want to go, and we're there. Now, because S3 is integrated with the other AWS ecosystems, we can do actually really cool things with this global deploy. We have some batch jobs that we do that are really intensive in terms of compute and data, and we want to run those in Spot because it's a lot more cost effective. But the problem is in the US, when it's daytime, Spot availability is pretty low and the prices are higher. So what we can do is look at other centers like Ireland or Tokyo, which at that time it's usually night. So what we can do is use a feature of S3 called cross-region replication. So we can put the data for that job into a bucket, and then it'll automatically be copied to multiple centers. So when we fire up our Spot jobs, we can fire them up in any region on Earth that has the copy, and the data will be there automatically. And for us, we just have the job jump around the globe wherever the cheapest instances are. Now, it's really important for us to replicate that data beforehand, because if you're doing something like this and you try to download from a remote region, you're going to be burning instance time while you're downloading. You're incurring extra bandwidth fees because cross-region replication is cheaper. And the worst is, by the time you finish, you take extra time and the Spot market may have changed and you just lost all your savings. So doing this, we can get the lowest Spot price in multiple regions, and our jobs are a lot more timely because we don't have to wait for Spot capacity to appear in one particular region. Now, S3 has really helped us out with performance too, and from just a few files to the petabytes of files that we have now, it's been a really good performing system. And as long as you use good keys with it, S3 will partition automatically, so it'll grow as you grow. And because of that, we rarely notice any of the performance limitations of S3 in production. There's also several features that you can do that will accelerate your performance in particular situations. I already mentioned using CloudFront as a CDN if you have really heavy reads on particular files. There's also faster uploads with transfer acceleration that the previous talker mentioned, and that can really help out if you're uploading really big files. There's also two other features that are lower level that are very important to certain customers for us. One is TCP window scaling. And this one is sort of interesting because if you use a default TCP window of 64 kilobytes over something like an oceanic or a satellite link for a lot of our more remote customers, the 64 kilobyte window is actually going to cap your effective bandwidth by a great amount, and you're going to waste a lot of your capacity. Selective ACKs are also supported, and that's really good for mobile connections, and that's good for us because most of our customers are using mobile devices. On the subject of performance, there are a couple of days at Ring that are a lot bigger than others. You can probably guess them: Thanksgiving, Christmas, New Year's Eve. Actually, Super Bowl Sunday. These are all really big days for us because there's a lot of family visits and parties. But head and shoulders above the rest of them is H-Day or Halloween. And this is a graph of one of our cluster. Yeah, it's definitely a big event for us. This is a graph of our cluster load on this last Halloween just a month ago. And just for reference, over there on the left, that little hump is where we usually top off on a normal day. And over on the right is what happens when you have millions of kids running around, setting off motion detectors and pushing doorbells all at once all over the globe. And that orange dashed line there is actually our former all-time 1-minute maximum traffic record. And as you can see, we smashed through that by almost 300%, and not just for 1 minute, we were over it for many hours. So imagine you had to scale for your biggest ever traffic times 3 for just 1 day efficiently. And don't think that Europe and Asia don't celebrate too, because we also saw surges like this over there as well. Probably not kids walking around, but lots of partying. So with S3, it actually scaled to many, many terabits per second ingress. And we didn't have to pay anything extra for that capability. We didn't even have to change any code for that capability, which was really nice, so we could focus on other services. But I would like to shout out the AWS support teams for helping us through that day without any issues. And if S3 can handle an onslaught like this, there's not a whole lot in our production load that it can't. So that's a summary of how Ring uses S3. It was really easy for us to implement when we were very small, and it's grown with us. And with the features like storage classes and regions, triggers, and a bunch of other features, it's really responded to our demands and enabled us to put out really exciting features for our customers that we really couldn't do otherwise. All right, so thanks for coming out.
Thanks, Jason. That was awesome. So H-Day, I love it. That's, I guess, our Cyber Monday. So we feel your pain. Really, really cool. So last but not least, I'd like to introduce Armando Wershing, who's a Senior Business Development Manager of 4850 Labs. 4850 focuses on DevOps and Agile consulting and software development for their clients. Armando's going to explain how they used advanced functionality in the AWS Storage Gateway to make it simpler for their customers to interface with S3.
Hey, everybody. Thanks for joining us today. Again, my name is Armando Wershing, and I'm with 4850 Labs. We are a DevOps consultancy and software shop. What does that mean? Along with a lot of partners that we represent, Veristore and being our parent company and having the relationship with Amazon, we do a lot of software development. we started off with a lot of work around basically creating the abstractions between different automations and the orchestrations, writing a lot of code around that. And we realized, hey, there's a lot of ideas here that we can carry forward. There's a lot of integrations across these really cool tools that are out there that we can bring to light and make it easier to use these tools together in that full-on CI/CD stream out to production. The first one, we actually just went live about a month ago with the tool. The company actually just went live about 2 months ago. And it's an integration between Splunk and Atlassian Jira Service Desk. And if you are familiar with those tools, then you know Jira Service Desk, ticketing, event, incident management, et cetera, issue management. Splunk, the all-around cool tool for going out there and diving deep into logs and machine data and finding out how did things happen, why did things happen, trigger events via real-time search. So the two together kind of married really, really nicely. So what we put together was this ability for, if you're in a Splunk place, to be able to see this data, whether you're how many tickets are open and you're trying to do an operational read, what the burn down rate is for all the tickets that are opening because of an incident event, things like that. And then, of course, being able to, if somebody's looking at a ticket in Jira, being able to click a link and take them directly to Splunk, right? Having some data of the incident already there, but take them to Splunk in order to really do a deeper dive into all the machine data and maybe do a little bit deeper root cause analysis. These are all really great ideas, but with services like this that are either on the cloud, right, or mostly on the cloud or on-prem, or a combination of both, one being on the cloud, one being on-prem, how do we deliver that connectivity? And so that's where AWS came in a variety of the tools that are there. We leverage EC2, S3, EFS, a lot of these tools within our connection to build an intermediary service that runs out on the cloud, scales up and down as needed. We manage that in order to be able to support rising growth, which obviously we're having very good luck with, and manage that connectivity between, say, an Atlassian cloud offering of Jira Service Desk and a customer's in-house Splunk server. And so we're able to build that and offer that intermediary in the service in the cloud. That's how we leverage this, a lot of the AWS pieces around this particular software product. There's a couple pieces there, especially for very security-conscious customers, being able to roll things out on their own VPC and having their own dedicated intermediary service if that's what they want. Or for some customers that have asked us, we want to move off the cloud. We want the enhanced security features of running on the more behind the firewall offerings from Atlassian, run our intermediary service for those two things and host and manage everything there yourself. So we fall into that role of the typical hosted managed service offering for some other software out there. And we use AWS as well for that as well. Some of the basic reasons we went and chose this is fault tolerant, multi-zone, RDS for the environments. Having that ability to have HA built in, right, out of the box, basically. Almost, depending on the situation, almost not really a need for actual backups because of the fault tolerance of multi-zone RDS. Being able to develop rapidly. So we are actually, there's other software tools. We have a concept we like to call JET, right, just enough tool. And we have these other software projects that are coming down the line where we're trying to build just enough tool that's needed to enable a particular CI/CD or orchestration or automation within the most common tool sets or frameworks that are out there. And to do that, we're leveraging some of these more advanced, like CloudFront, right? As some of the S3s, the infrequent access buckets, things like that. So the rapid innovation, when you look at the trend of what AWS has done over the course of, say just 1 year, how many new features have been released, that enables us to take and pick and choose the best of those that apply for our features. And the scalability for growth, for obvious reasons, the ability to go out there and as everybody else here at the stage has spoken to, how quickly you can ramp up. We can go from a single instance prototype stage, right, in 10 days, to running, thousands of transactions through it, hundreds of customers, as fast as possible, as much as we need, right, without having to wait for storage, wait for the network, wait for the infrastructure to roll in. Even though our parent company provides those kinds of services, we actually rolled it out on the cloud just for speed, right, purely for speed to market on AWS. And lastly, what everybody really looks at the end, internally, especially me being on the business side of things as opposed to the development side of things, the cost margin, right? Being able to find the solution that gives you the most margin, whether that's an S3, the various S3 options for storage, whether that's dedicated compute, doing that 3-year commitment for dedicated compute as you're looking forward and seeing your growth and saying, let's just go ahead and commit to this for 3 years because we think we're going to use it, and if not, we'll find another way to use it. So there's a lot of features of that that allow us to really gain from that cost margin benefits of AWS. So that is it. I'm actually the last one, and like I said, it was going to be short and sweet for me. If there's any questions, feel free. Otherwise, hand it back.
Awesome. Thank you. So we really buzzed through that very quickly. Yeah.